The afternoon of March 23, 1945, and Major Hans Scheffer of the Wehrmacht Engineer Corps stood on the eastern bank of the Rhine River near Wessel, watching something that shouldn't have been possible. Through his field glasses, he could see American engineers working in the open, under sporadic artillery fire, assembling what looked like children's construction toys on the far shore. Steel girders, wooden planks, and floating pontoons were being connected with a speed that violated everything he knew about bridge construction. His engineering education at the Technical University of Berlin, his 4 years of combat experience building defensive fortifications across Europe, his intimate knowledge of what the Rhine represented as Germany's final natural barrier. All of it told him the Americans were attempting something that would take days, maybe weeks, to complete. He lowered his binoculars and turned to his subordinate. "They're wasting their time," he said, though his voice carried less conviction than his words. "No bridge can span the Rhine in less than 48 hours under combat conditions." By dawn the next morning, 3 full American divisions would be across the river, and Major Scheffer would be asking himself a question that thousands of German officers were confronting in those final months of the war. How had they so completely misunderstood their enemy's capabilities? This is the story of how American engineering, backed by industrial capacity that defied comprehension, shattered German military confidence in a way that tank battles and aerial bombardment never could. Because sometimes the most devastating weapon isn't the one that kills soldiers, it's the one that kills hope. And nothing killed German hope faster than watching the supposedly inferior Americans accomplish in hours what German engineering doctrine said should take days. By March of 1945, the Rhine River represented more than just a geographical feature on military maps. For Germans, it was the last psychological barrier between the Allied armies and the heartland of the Reich. The river itself seemed designed by nature to be impassable, flowing 400 feet wide in most places. With currents reaching 6 miles per hour during spring floods, it had served as a natural fortress since Roman times. Medieval castles lined its banks precisely because the Rhine was so difficult to cross. German military planners had spent the previous 6 months turning every bridge approach into a fortress, every bend in the river into a killing zone. German engineering expertise had always been a source of national pride. The Reich's engineers had pioneered modern concrete construction, designed the Autobahn system, and created some of the war's most sophisticated weapons. Men like Albert Speer and Fritz Todt had transformed German industrial capacity into a war machine that had conquered most of Europe. When German engineers looked at the Rhine, they saw a defensive line that would require weeks of preparation to breach, even for an army as large as the one approaching from the west. The prevailing German military doctrine held that river crossings were among the most complex and vulnerable operations in warfare. You needed to establish bridgeheads under fire, suppress enemy artillery, clear minefields on both banks, and then construct bridges capable of supporting tanks and heavy equipment, all while defending against counterattacks. German engineering manuals estimated that constructing a bridge capable of supporting armor across a river like the Rhine would require a minimum of 3 to 4 days, assuming favorable conditions and minimal enemy interference. Under combat conditions, a week or more seemed reasonable. This confidence wasn't entirely misplaced. Throughout the war, German defenders had successfully delayed Allied river crossings across Europe. At the Rapido River in Italy, American forces had suffered devastating casualties trying to establish a bridgehead. At the Roer River in February 1945, the Germans had demonstrated their defensive mastery by flooding the valley and delaying the Allied advance for 2 weeks. The Rhine, wider and faster than either of these rivers, seemed to offer even better defensive prospects. What German commanders failed to appreciate was that they were no longer fighting the same American army that had landed in Normandy 9 months earlier. The force approaching the Rhine in March 1945 had been transformed by experience, supplied by an industrial base that produced equipment faster than it could be used, and organized with a logistical sophistication that German observers consistently underestimated. The American military had become a machine that learned, adapted, and improved with terrifying efficiency. The technological centerpiece of this transformation was something that looked deceptively simple: the Bailey Bridge. Designed by British civil engineer Donald Bailey in 1940, this modular bridge system could be assembled without heavy equipment, required no specialized tools, and could be constructed under combat conditions by regular infantry with minimal training. Each section weighed less than 600 pounds, light enough for 6 men to carry. The panels connected with pins rather than bolts, meaning assembly was quick and required no precision machining on site. But the true genius of the Bailey Bridge wasn't its individual components. It was the system's flexibility. Engineers could double or triple the load-bearing capacity by adding parallel panels. They could extend the bridge's length by simply adding more sections. Most remarkably, they could construct the entire structure on one side of the river and then push it across the gap using a specialized launching nose, meaning engineers didn't need to work in the middle of the river under fire. American military engineers had taken Bailey's design and integrated it into a comprehensive river crossing doctrine that combined speed, redundancy, and overwhelming force. Each American corps had its own engineer brigade, equipped with hundreds of tons of prefabricated bridge components, specialized vehicles for riverbank preparation, and detailed plans for multiple crossing sites. Unlike German engineering, which emphasized careful planning and precision execution, American doctrine accepted that some bridges would be destroyed by enemy fire. The solution wasn't to make each bridge perfect. It was to build so many bridges so quickly that the enemy couldn't destroy them all. The contrast in military philosophy was stark. German engineering focused on creating permanent, sophisticated structures that could withstand punishment. American engineering focused on creating temporary, functional structures that could be replaced rapidly. One approach valued quality and permanence. The other valued speed and redundancy. As the Allies approached the Rhine, it was becoming clear which philosophy was better suited to modern mechanized warfare. Lieutenant Colonel David Pergrin commanded the 291st Engineer Combat Battalion, part of the First Army's assault on the Rhine. A civil engineer from Pennsylvania before the war, Pergrin had overseen bridge construction across France and Belgium, learning hard lessons about what worked under fire and what didn't. His battalion had constructed over 100 bridges since D-Day, ranging from simple wooden spans over streams to complex Bailey bridges across major rivers. By March 1945, his men could assemble a Bailey bridge in their sleep. What made Pergrin's battalion effective wasn't just technical skill. It was their understanding of combat engineering as a combined arms operation. Bridge construction had to be coordinated with artillery support to suppress enemy fire, infantry advances to secure the far shore, and air support to prevent German reinforcements from reaching the crossing sites. Pergrin's planning documents for the Rhine crossing ran to hundreds of pages, detailing every aspect of the operation from the positioning of bridge components to the rotation schedule for exhausted crews. The scale of American preparation was staggering. By early March, the 1st and 9th Armies had stockpiled enough bridging equipment along the Rhine to span the river 50 times over. Thousands of tons of Bailey bridge components sat in warehouses and staging areas. Specialized equipment filled motor pools, bulldozers for preparing approach roads, cranes for positioning heavy sections, boats for ferrying advance parties, and amphibious vehicles for the initial assault waves. The American military had reduced river crossing from an improvised operation to an industrial process, complete with detailed timelines and quality control standards. German intelligence officers monitoring these preparations understood that a major crossing was imminent, but they fundamentally misread what they were seeing. The sheer quantity of American equipment suggested that the Allies were planning for a long, difficult operation. German analysts estimated that the Americans would need at least a week to establish functioning bridges, possibly longer if German artillery could disrupt the construction sites. They believed time was on their side, that the Rhine would give them breathing room to regroup and reorganize their shattered divisions. This miscalculation stemmed from a persistent failure to comprehend American industrial capacity. Throughout the war, German commanders had consistently underestimated how quickly the United States could produce and deliver equipment to the battlefield. When German intelligence reported that American factories were producing a bomber every hour or a tank every 30 minutes, German generals dismissed these figures as propaganda. Surely no nation could sustain such production rates. The numbers had to be exaggerated. But the numbers weren't exaggerated. By 1945, American war production had reached levels that would have seemed like science fiction just 5 years earlier. The United States was producing more military equipment in a single month than Germany produced in an entire year. This wasn't just a matter of having more factories. It was a fundamental difference in industrial organization. American mass production techniques, pioneered by Henry Ford and refined across multiple industries, had been applied to war manufacturing with devastating effectiveness. The Rhine crossing doctrine that American engineers brought to the river in March 1945 was the product of extensive experience and systematic learning. Unlike the improvisational approaches that had characterized early American operations in North Africa and Italy, the Rhine assault would follow detailed procedures developed through trial and error across dozens of river crossings. Every engineer battalion had practiced the operation repeatedly. Every soldier knew his specific role. Every piece of equipment had been tested under combat conditions. The key innovation was parallel construction. Rather than building one bridge at a time, American engineers would construct multiple bridges simultaneously at each crossing site. If German artillery destroyed one bridge, 3 others would continue operation. This redundancy extended to every aspect of the operation. Engineers prepared multiple approach roads to each bridge site, prepositioned backup equipment at strategic locations, and organized construction crews in rotating shifts to maintain continuous work around the clock. On the night of March 23, 1945, the assault began at multiple points along the Rhine. At Remagen, where American forces had captured an intact bridge 2 weeks earlier, engineers were already constructing additional crossings to supplement the damaged Ludendorff Bridge. Near Oppenheim, Patton's Third Army launched a surprise crossing with minimal preparation, ferrying troops across in assault boats before the Germans could react. But the main effort, the crossing that would demonstrate American engineering capability most dramatically, would take place near Wesel, where Field Marshal Bernard Montgomery had concentrated British and American forces for a massive set-piece assault. Montgomery's plan called for the most elaborate river crossing in military history. Thousands of artillery pieces would bombard German positions. Paratroopers would drop behind German lines to disrupt reinforcements. Smoke screens would obscure the river, and under this protective umbrella, American and British engineers would construct bridges at a rate that would overwhelm German defensive capacity. Lieutenant Colonel Pergrin's battalion drew one of the most exposed crossing sites, a stretch of river directly opposite German artillery positions on the Wesel Heights. His orders were straightforward but daunting. Construct a Class 40 Bailey Bridge, capable of supporting tanks, within 24 hours of the infantry assault. Intelligence estimates suggested German forces would subject the site to constant artillery and mortar fire. Casualty rates among the engineer crews were expected to reach 30%. Pergrin's men began their work at 0400 hours on March 24th, just as the first assault boats were crossing the river. Working in darkness, broken only by artillery flashes, and the occasional flare engineer team started positioning the bridge's foundation components on the western bank. Each Bailey panel was carried forward by hand, fitted into place, and pinned to the previous section. The work proceeded with mechanical precision. Lift, carry, position, pin, move to the next section. There was no time for hesitation or doubt. German artillery opened fire within minutes of the operation's start. Shells exploded along the riverbank, throwing up geysers of mud and water. Several engineers were killed in the first hour, but the work continued. This was the fundamental difference between American and German engineering doctrine. The Americans had accepted that casualties were inevitable and planned accordingly. Fresh crews rotated forward to replace wounded men. Equipment damaged by shrapnel was immediately replaced from stockpiles. The bridge construction never stopped. By 0600 hours, the bridge extended 50 feet from the western bank. By 0800 hours, it was halfway across the river. German observers watching from the heights above Wesel couldn't believe what they were seeing. The bridge was growing at a rate of approximately 30 feet per hour, far faster than German doctrine suggested was possible. More troubling, German artillery, firing as quickly as crews could load and aim, seemed unable to halt the construction. For every section destroyed, the Americans simply added another. What German commanders didn't understand was that the Americans had fundamentally reimagined the mathematics of bridge construction under fire. Traditional engineering doctrine assumed that each bridge section was precious, that losing components to enemy fire represented a serious setback. American doctrine started from a different premise. Components were expendable, men were somewhat expendable, but time was absolutely precious. The goal wasn't to protect each bridge section. It was to build faster than the enemy could destroy. This philosophy extended to personnel management. Pergrin had organized his battalion into 3 complete construction teams. While one team worked on the bridge, another rested, and a third prepared equipment and supplies. Every 2 hours, the teams rotated. This meant that men working under fire never became so exhausted that their efficiency declined. It also meant that casualties in one team didn't halt the overall operation. The bridge kept growing. By noon on March 24th, Pergrin's bridge spanned the Rhine. Engineers drove the first jeep across at 12:17 hours, just 8 hours after construction had begun. Within another hour, the bridge was supporting truck traffic. By evening, Sherman tanks were crossing. The bridge that German engineers had estimated would take 3 to 4 days to construct under ideal conditions had been completed in less than 12 hours under constant enemy fire. But Pergrin's bridge was just one of many. Along a 50-mile stretch of the Rhine, American and British engineers constructed over 20 bridges in the first 48 hours of the crossing operation. Some were simple treadway bridges for infantry and light vehicles. Others were heavy Bailey bridges capable of supporting the heaviest tanks. A few were even more sophisticated, floating bridges that could be opened to allow boat traffic, then closed again for vehicle crossings. The rate of construction shattered every assumption German commanders had made about defensive operations on the Rhine. By March 26th, just 72 hours after the initial assault, over 100,000 Allied troops had crossed the river. By March 28th, the number exceeded 200,000. Entire armored divisions were streaming across bridges that the Germans had been certain would take weeks to construct. Major Hans Schäfer, the Wehrmacht engineer who had dismissed American bridge-building efforts on March 23rd, found himself retreating eastward on March 27th, part of a disorganized withdrawal that bore no resemblance to the orderly defensive operations German doctrine prescribed. His engineering company, which had spent months preparing demolitions and defensive positions along the Rhine, had been bypassed and rendered irrelevant in less than 4 days. In his final report before his unit surrendered in early April, Schäfer attempted to explain what had happened. "The Americans do not build bridges the way we were taught," he wrote. "They do not care about elegance or permanence. They build the minimum structure necessary, and they build it with such speed that our artillery cannot destroy them faster than they appear. More importantly, they seem to possess unlimited supplies of bridging equipment. We destroyed one bridge completely, only to watch them begin constructing another 50 meters away within the hour. It is not that their engineering is superior to ours. It is that they have so much of everything that superiority becomes irrelevant." Schäfer's observation captured something essential about the American way of war in 1945. Quality had become almost secondary to quantity and speed. A bridge that was merely adequate but could be built in 8 hours was infinitely more valuable than a perfect bridge that required 3 days. This wasn't a rejection of engineering excellence. It was a recognition that in modern mechanized warfare, tempo mattered more than perfection. The psychological impact on German defenders was devastating. Officers who had fought across Russia, Africa, and Western Europe, who had faced Soviet mass attacks and British methodical offensives, found themselves unable to comprehend what they were confronting on the Rhine. The Americans weren't just winning. They were winning with such ease, such overwhelming material superiority, that resistance seemed futile. When your artillery destroyed an enemy bridge only to see 2 more appear overnight, when your defensive positions were bypassed by bridges you didn't know existed, what was the point of continuing to fight? German soldiers began surrendering in unprecedented numbers. Entire companies walked into captivity rather than face the advancing American columns. The surrender rate along the Rhine in late March exceeded anything seen earlier in the war. Veterans who had held positions against impossible odds in Russia or Normandy simply gave up when confronted with American logistics and engineering. It wasn't that American soldiers fought better. It was that American resources made fighting seem pointless. The Rhine crossing operation's success reverberated far beyond the immediate tactical gains. Within 2 weeks of the initial assault, Allied forces had advanced over 100 miles into Germany, encountering minimal organized resistance. The Wehrmacht, which had managed to slow the Allied advance through the winter months, simply disintegrated. Units that had fought tenaciously in the Ardennes or along the Siegfried Line abandoned positions without firing a shot once they realized the Rhine had been crossed so quickly. General Dwight Eisenhower, reviewing the operation's results, noted in his report to the combined chiefs of staff that the Rhine crossing had proceeded with fewer casualties than anticipated precisely, because German defenders had lost the will to resist. "The enemy's morale appears to have been broken not by our firepower, but by our logistics," he wrote. "German soldiers who witnessed our bridge construction capacity seem to have concluded that further resistance was mathematically impossible." This psychological collapse had material roots. German commanders conducting after-action assessments realized that American engineer battalions had constructed bridges at a rate that exceeded German artillery's ability to destroy them by a factor of approximately 4-to-1. For every bridge German guns managed to damage or destroy, Americans completed 4 more. This ratio made defensive operations on river lines essentially futile. If you couldn't prevent the enemy from crossing rivers, one of the fundamental principles of defensive warfare became obsolete. The industrial statistics behind this capability were staggering. By March 1945, American factories had produced over 60,000 tons of Bailey Bridge components, enough to span the Rhine over 300 times. These components were distributed throughout the European theater, pre-positioned at strategic locations, ready for immediate use. German intelligence officers examining captured American supply dumps found warehouse after warehouse filled with bridging equipment, much of it still in factory packaging. One captured German logistics officer, interviewed by American intelligence in April 1945, provided a particularly revealing perspective. "We knew America was wealthy," he said, "but we thought wealth meant comfort and luxury goods. We did not understand that American industry could produce military equipment with the same efficiency it produced automobiles. When we saw entire bridges being assembled from components that looked like they came from a factory assembly line, we realized we were fighting an enemy whose industrial capacity was beyond our comprehension." This realization came too late to affect German strategy, but early enough to influence the final weeks of the war. Wehrmacht commanders, understanding that defensive operations were now pointless, began focusing on delaying actions designed primarily to allow civilian populations to flee westward ahead of Soviet forces. The fighting continued, but its character changed. German soldiers were no longer fighting to win or even to prevent defeat. They were fighting to buy time for refugees and to avoid Soviet captivity. The human cost of the Rhine crossings, while significant, was far lower than Allied planners had anticipated. Pergrin's battalion, which had expected 30% casualties, suffered approximately 8% killed and wounded. Across all Rhine crossing operations, American engineer casualties totaled fewer than 1,500 men, a fraction of what pessimistic estimates had predicted. The combination of overwhelming artillery support, air superiority, and rapid construction tempo had made the crossings far less costly than anyone had expected. German casualties were harder to calculate, but Allied intelligence estimates suggested that over 50,000 German soldiers surrendered in the immediate aftermath of the Rhine crossings, often without significant combat. Entire divisions simply walked into captivity once they realized their defensive positions had been bypassed. The morale collapse triggered by the successful crossings proved more devastating to German combat power than the actual fighting. The engineering lessons learned on the Rhine influenced military doctrine for decades. The U.S. Army's post-war analysis of river crossing operations identified speed and redundancy as the critical factors in success. Traditional engineering doctrine, which emphasized careful planning and precision execution, was supplemented with new principles. Accept casualties, expect equipment losses, build faster than the enemy can destroy, and maintain multiple crossing sites simultaneously. These principles reflected a broader transformation in how American military planners understood modern warfare. The Rhine crossings demonstrated that industrial capacity, properly organized and deployed, could be as decisive as tactical brilliance or operational innovation. You didn't need to outfight the enemy if you could simply overwhelm them with resources deployed faster than they could react. The contrast with German military culture was profound. German engineering excellence, German tactical sophistication, and German operational skill had all been real. Wehrmacht commanders had demonstrated remarkable ability to conduct mobile defense, to coordinate combined arms operations, and to maximize the effectiveness of limited resources. But none of this mattered when confronting an enemy who could replace losses faster than you could inflict them, who could build bridges faster than you could destroy them, and who approached warfare as an industrial problem to be solved through mass production and systematic organization. Major Hans Scheffer survived the war and returned to civilian life in West Germany, where he worked as a structural engineer helping to rebuild his shattered nation. In a 1953 interview with an American military historian researching Rhine crossing operations, Scheffer reflected on his experience watching American engineers work on that March afternoon in 1945. I had been taught that engineering was about precision, about calculating loads and stresses exactly, about creating structures that would endure, he said. The Americans taught me that engineering could also be about speed, about accepting imperfection in service of rapid deployment, about building things that were good enough rather than perfect. It was a different philosophy entirely, and it was more suited to modern warfare than anything we had developed. He paused, then added, "We lost the war in many places, at Stalingrad, in Normandy, in the skies over Germany. But I think we lost it most completely on the Rhine, because that was where we finally understood that we were not just fighting the American army. We were fighting American industry, American logistics, and an organizational capacity that made our best efforts seem antiquated. You cannot win a war when your enemy can build bridges faster than you can destroy them. It is a mathematical impossibility. This mathematical impossibility, the simple calculation that American construction capacity exceeded German destruction capacity, represented the ultimate vindication of industrial warfare. The United States had transformed war from a contest of military skill into a contest of productive capacity, and in that contest, there was never any doubt about the outcome. The Rhine Bridge operations also revealed something about the nature of technological superiority in warfare. German military technology in many areas remained superior to American equivalents. German tanks had better armor and more powerful guns. German artillery had greater range and accuracy. German small arms were often more sophisticated, but none of this technological excellence mattered when confronting American organizational and industrial superiority. The Bailey Bridge, the centerpiece of American river crossing success, wasn't particularly sophisticated technology. It was a clever application of modular design principles, but there was nothing about it that German engineers couldn't have created. What made it effective wasn't the technology itself, but the system surrounding it. The mass production capacity that created thousands of tons of components, the logistical organization that positioned those components where they were needed, the training that allowed ordinary soldiers to assemble complex structures, and the doctrine that accepted casualties and equipment losses as necessary costs of rapid deployment. This systemic approach to warfare represented something fundamentally new in military history. Previous wars had been won through superior tactics, better weapons, or more skillful commanders. World War II, particularly its final phase, was won through superior organization, industrial capacity, and logistical sophistication. The side that could produce more equipment, deploy it faster, and accept higher replacement rates would win regardless of tactical or technological considerations. The legacy of the Rhine crossings extended beyond immediate military applications. The engineering techniques pioneered during the operation influenced post-war infrastructure development. Bailey bridges, originally designed for military use, became standard equipment for civilian emergency response. When floods, earthquakes, or other disasters destroyed permanent bridges, Bailey bridge components could be rapidly deployed to restore transportation networks. The same principles of modular design and rapid assembly that had won battles also proved valuable in humanitarian operations. On a broader level, the Rhine operations vindicated the American approach to war. The belief that industrial democracy could outproduce and outlast any totalitarian system through superior organization and resource mobilization. The Soviet Union contributed more soldiers and suffered greater casualties in defeating Nazi Germany, but the United States provided the industrial foundation that made Allied victory possible. American factories supplied not just American forces, but British, Soviet, and other Allied armies with equipment that no single nation could have produced alone. The Rhine bridges themselves, temporary structures designed to last weeks or months, served for years after the war. Some remained in use until permanent bridges could be reconstructed, carrying civilian traffic and reconstruction materials into the heart of devastated Germany. These practical, unpretentious structures, dismissed by German engineers as crude and inelegant, proved more durable and useful than anyone had anticipated, a fitting metaphor for the American approach to war. By April 1945, less than 6 weeks after the Rhine crossings, American forces had advanced to the Elbe River, where they halted to allow Soviet forces to capture Berlin. The rapid advance was made possible by the logistics infrastructure established during the Rhine operations. Engineers who had constructed bridges under fire in March were building supply routes across Germany in April, maintaining the momentum that would end the war in Europe. When Germany surrendered on May 8, 1945, the Rhine crossings were recognized as one of the operation's decisive turning points. Not because they were the war's largest battles or resulted in the highest casualties, but because they demonstrated, more clearly than any other operation, the futility of continued German resistance. An army that could construct 20 bridges across Germany's greatest natural barrier in 48 hours, despite enemy opposition and terrible weather, was simply unstoppable. Major Scheffer's question, how had they so completely misunderstood their enemy's capabilities, had a straightforward answer. German commanders had understood American resources in abstract terms, but failed to appreciate how those resources would be employed. They knew America was wealthy and industrial, but assumed that wealth would be squandered through inefficiency, and that industrial capacity would be limited by organizational incompetence. The Rhine crossings proved both assumptions catastrophically wrong. The American military in 1945 represented something historically unprecedented. An armed force that combined democratic values with industrial efficiency, that valued individual initiative within systematic organization, and that approached warfare not as an art form, but as an engineering problem to be solved through superior resources and better organization. This combination proved invincible not because it was perfect, but because it was sustainable. America could afford mistakes, could replace losses, and could maintain pressure indefinitely, advantages that no amount of German tactical skill could overcome. Standing on that Rhine riverbank in March 1945, watching American engineers assemble their crude bridges with impossible speed, Major Scheffer had witnessed the future of warfare. A future where industrial capacity mattered more than military tradition, where organizational efficiency trumped tactical brilliance, and where the nation that could produce and deploy resources fastest would win regardless of other considerations. It was a future that Germany, with its emphasis on military excellence and technological sophistication, was utterly unprepared to face. The bridges are gone now, replaced long ago by permanent structures, but the lesson they taught endures. In modern warfare, the side that can build faster than the enemy can destroy, that can replace losses faster than they accumulate, and that can maintain logistical momentum despite all obstacles, possesses an advantage that no amount of courage or skill can overcome. Sometimes victory isn't about fighting better, it's about building faster. The full implications of the Rhine crossings became clear not in March 1945, but in the months and years that followed, as historians and military analysts attempted to understand how Germany's final defensive line had collapsed so completely. The numbers told part of the story. 23 bridges constructed in the first 48 hours, over 300,000 troops crossed in the first week, less than 2,000 Allied casualties across all crossing operations. But statistics alone couldn't explain the psychological transformation that occurred on both sides of the river during those critical days. Lieutenant Colonel David Pergrin returned to civilian life in Pennsylvania after the war, resuming his career as a structural engineer. He rarely spoke publicly about his wartime experiences, but in a 1978 interview for the U.S. Army Corps of Engineers Oral History Project, he reflected on what the Rhine crossing had meant to the men who built those bridges. "We knew we were doing something important," he said, "but we didn't realize we were demonstrating a completely different way of thinking about engineering problems. We weren't trying to build beautiful bridges or permanent structures. We were solving a logistical equation. How many men can we move across this obstacle in the shortest possible time, accepting that some equipment will be destroyed and some men will be casualties? It was brutal mathematics, but it was effective." That brutal mathematics represented a philosophical shift in how America approached not just warfare but large-scale organizational problems. The Rhine crossings demonstrated that complex challenges could be overcome through systematic planning, resource abundance, and acceptance of iterative failure. You didn't need perfect solutions. You needed adequate solutions deployed rapidly and repeatedly until the problem was solved. This approach, refined through wartime necessity, would later influence everything from American highway construction to the space program. The German military's response to the Rhine crossings revealed how thoroughly the operation had shattered defensive doctrine. Wehrmacht training manuals from 1946, prepared for a military that would never again exist in its previous form, included extensive analysis of the American river crossing methods. These manuals acknowledged that traditional defensive operations on river lines had become obsolete when facing an enemy with unlimited bridging capacity. The recommended response was tellingly pessimistic. Withdraw to positions beyond the river before the enemy could establish crossings, because once American engineers began construction, stopping them was mathematically impossible. Field Marshal Albert Kesselring, one of Germany's most capable defensive commanders, examined the Rhine operations while preparing his testimony for post-war military tribunals. In his private papers, later published in 1952, he wrote, "The Americans won the Rhine crossings before the first soldier entered the water. They won through preparation so thorough, resources so abundant, and planning so comprehensive that our defensive efforts were rendered irrelevant." This was not warfare as I had learned it. It was industrial problem-solving applied to military objectives. We had no doctrine, no training, no experience that prepared us for this approach. Kesselring's observation highlighted a crucial point. The Rhine crossings weren't primarily a military victory. They were an industrial and organizational victory that happened to take place in a military context. The American forces that crossed the Rhine in March 1945 bore little resemblance to the army that had landed in Normandy 9 months earlier. They had evolved into something unprecedented, a military force that operated more like a vast manufacturing enterprise than a traditional army. This transformation was visible in how American units approached problems. When Pergrin's engineers encountered unexpected difficulties with riverbank stability at their crossing site, they didn't stop work to develop an elegant solution. They diverted bulldozers from another crossing site 3 miles away, reinforced the banks with whatever materials were available, including demolished German fortifications, and continued construction. The bridge's foundation wasn't perfect, but it was adequate, and adequate was sufficient when speed mattered more than perfection. German engineers watching this improvisation found it deeply unsettling. Their training emphasized precise calculations, careful material selection, and proper construction sequences. The American approach seemed chaotic, wasteful, and unprofessional, yet it worked. The bridges held, the tanks crossed, and the German defensive line collapsed. This cognitive dissonance, watching methods you knew were wrong produce results that were undeniably right, proved more demoralizing than combat losses. The psychological impact extended beyond military personnel. German civilians living near the Rhine crossings witnessed the operation and spread word eastward about what they had seen. Refugees fleeing the advancing Allies carried stories of bridges appearing overnight, of American supply convoys stretching to the horizon, of equipment so abundant that damaged vehicles were simply abandoned rather than repaired. These accounts, filtering through German society in April and May 1945, contributed to the general collapse of civilian morale that made Germany's final surrender inevitable. One particularly revealing account came from a German schoolteacher named Wilhelm Hoffmann, who lived near the Wessel crossing site. In his diary, published posthumously in 1963, he described watching American engineers work. They moved like factory workers, each man performing his specific task with mechanical efficiency. There was no drama, no heroism in the traditional sense, just relentless organized labor that produced results hour after hour. I realized that this was what we were fighting, not soldiers, but an industrial system that could not be stopped because it could not be exhausted. Hoffmann's observation captured something essential about American military power in 1945. The United States had industrialized warfare so completely that traditional military virtues, courage, tactical skill, operational brilliance, became secondary to organizational capacity and resource management. This didn't make American soldiers less brave or less skillful, but it meant their bravery and skill were amplified by an industrial and logistical foundation that their enemies couldn't match. The Rhine bridges also represented a turning point in how engineers were viewed within military organizations. Before World War II, engineers were support troops, important but subordinate to combat arms. The Rhine crossings demonstrated that engineers could be decisive in determining battle outcomes. Post-war American military doctrine elevated engineering to a position of equal importance with infantry, armor, and artillery. The U.S. Army Engineer School at Fort Leonard Wood developed courses based on Rhine crossing operations, teaching generations of officers that mobility and logistics were weapons as powerful as guns or bombs. This doctrinal evolution influenced Cold War military planning. American strategists, analyzing potential conflicts with the Soviet Union, recognized that river crossings would be critical in any European war. They invested heavily in bridge-building technology, developing ever more sophisticated systems that could span wider rivers in shorter times. The M4T6 floating bridge, introduced in the 1950s, could support 70-ton tanks and be assembled even faster than Bailey bridges. These systems, direct descendants of the equipment used on the Rhine, became standard NATO equipment and remained in service for decades. The Soviet military, studying American Rhine crossing operations through captured German documents and post-war analysis, drew different conclusions. Soviet doctrine emphasized overwhelming force and acceptance of casualties, but it incorporated American lessons about speed and redundancy. Soviet engineer units trained to construct multiple bridges simultaneously, accepting that some would be destroyed, focusing on maintaining momentum rather than protecting individual structures. In this sense, the Rhine crossings influenced military thinking on both sides of the Cold War divide. Major Hans Scheffer's post-war career illustrated how German engineers absorbed these lessons. Working on reconstruction projects throughout the 1950s, he increasingly adopted American-style approaches: modular construction, rapid deployment, acceptance of adequate rather than perfect solutions. When asked by younger German engineers why he didn't emphasize the precise, elegant techniques he had learned before the war, he reportedly said, "I watched the Americans build bridges on the Rhine. They taught me that sometimes good enough, delivered quickly, is better than perfect, delivered late. It is a hard lesson for a German engineer to learn, but it is true nonetheless." The broader strategic implications of the Rhine crossings extended beyond engineering doctrine. Allied intelligence analysts, reviewing German communications from late March and early April 1945, noted a marked change in tone. Before the Rhine crossings, German commanders still discussed defensive strategies and potential counteroffensives. After the crossings, communications focused almost exclusively on delaying actions and withdrawal schedules. The realization that Germany's greatest natural barrier had been overcome so easily convinced even the most optimistic German officers that the war was lost. This psychological collapse had concrete military consequences. Wehrmacht units that had fought tenaciously in the Ardennes or along the Siegfried Line surrendered readily once they crossed paths with American forces east of the Rhine. Desertion rates spiked. Officers reported increasing difficulty maintaining discipline as soldiers concluded that further fighting served no purpose. The Rhine crossings hadn't just breached a defensive line, they had breached German will to resist. The operation's success also validated American grand strategy. Throughout the war, U.S. planners had emphasized industrial mobilization over rapid military expansion. They had prioritized logistics and supply over immediate combat power. Critics had argued that this approach was too slow, that America should have committed forces to Europe earlier and more aggressively. The Rhine crossings demonstrated that patient industrial preparation created advantages that tactical brilliance alone could never achieve. General Eisenhower, writing his post-war memoirs, devoted considerable attention to the Rhine operations. "The crossing of the Rhine," he wrote, "was not a battle in the traditional sense. It was a demonstration of organizational superiority, of what happens when an advanced industrial nation applies its full capacity to a military problem. We won not because our soldiers were braver than German soldiers. They were not. We won not because our generals were more skilled. That is debatable. We won because we could bring more resources to bear, more quickly, and sustain them longer than any enemy could match. That is the American way of war." Eisenhower's assessment, while perhaps overly modest about American tactical and operational skill, identified the fundamental advantage the United States possessed in World War II. American military power rested on an industrial foundation that could absorb losses, learn from mistakes, and continuously improve. The Rhine crossings were the culmination of this learning process. the moment when American organizational and industrial advantages achieved their fullest expression. 70 years after those March days in 1945, the Rhine crossing sites are marked by modest memorials and historical markers. The bridges themselves vanished long ago, replaced by elegant permanent structures that serve modern highway traffic. But the principles those temporary bridges embodied, speed over perfection, redundancy over protection, organization over improvisation, continue to influence military doctrine and large-scale project management worldwide. Standing at the Wesel crossing site today, you can barely imagine what occurred there in March 1945. The river seems too wide, the opposite shore too distant, the whole proposition too difficult to accomplish in 8 hours under fire. Yet it happened, documented in thousands of photographs, recorded in hundreds of after-action reports, remembered by the survivors who built those bridges and those who crossed them. Major Hans Scheffer's question, how had they so completely misunderstood their enemy's capabilities, ultimately had a simple answer. German commanders had understood American wealth, but misunderstood what that wealth meant in practical terms. They had seen American industrial statistics, but failed to grasp how industrial capacity could be translated into battlefield advantage. They had recognized American organizational sophistication, but underestimated how organization could substitute for traditional military excellence. The Rhine bridges were the physical manifestation of this misunderstanding. Every steel beam, every wooden plank, every floating pontoon represented not just engineering capability, but industrial capacity, organizational skill, and logistical sophistication that German commanders had failed to anticipate. The bridges weren't weapons in any traditional sense, but they were decisive nonetheless. Decisive because they demonstrated that America could accomplish in hours what Germany needed days to achieve, because they showed that American resources were essentially unlimited, and because they proved that further resistance was mathematically futile. In the end, Major Scheffer had been right that March afternoon when he told his subordinate that the Americans were wasting their time attempting to bridge the Rhine so quickly. They were wasting time by German standards, using German methods, following German engineering principles. But the Americans weren't doing any of those things. They were applying industrial production techniques to military engineering, accepting inefficiency in individual efforts to achieve efficiency in aggregate outcomes, and recognizing that speed multiplied by abundance could overcome any obstacle. The lesson the Rhine crossings taught, that organizational capacity and industrial abundance could be more decisive than tactical brilliance or technological superiority, shaped the post-war world. It influenced how nations approached military preparedness, infrastructure development, and large-scale problem-solving. It validated the American belief that democratic capitalism, properly organized, could outproduce and outlast any competing system. But perhaps the most enduring lesson was simpler and more human. Sometimes what looks impossible is only impossible using familiar methods. Sometimes the solution isn't to build better bridges, but to build adequate bridges faster. Sometimes victory belongs not to those who refuse to accept failure, but to those who accept small failures repeatedly in pursuit of ultimate success. The American engineers who built those Rhine bridges in March 1945 weren't heroes in the traditional sense. They were workers, applying industrial logic to military problems, succeeding through organization and abundance rather than brilliance or bravery. And in doing so, they helped end history's most devastating war, one bridge at a time.